The 2013 paper 2. 2013 paper 2, and we are starting off with height below on the right consists of 6 squares. So squares means the length and the width are the same. So 2 by 2. It can be folded to form a cube. Find the surface area of the cube. So if you were to fold these, like so, and then you fold this side once, twice, 3 times, what you're going to end up with is a cube. Okay, and the cube we're looking for is we got to find the surface area of the cube. So a cube has 6 sides, okay? So if you remember from cubes, they have 6 sides, okay? So 1, 2, 3, 4, top and bottom, 5 and 6, okay? So what we have to do is we have to find the surface area of each square. So remember, a square, to get the area of the square, you multiply length by width, okay? So area equals length by width. So we're going to get 2 multiplied by 2, which is 4. Now remember, each one is going to be worth 4. So there's basically 6 sides. So multiply 6 by 4, and what you'll get is 24 centimeters squared. And that is the surface area of the cube. Next one. A food production company has decided between a closed cylindrical tin and a rectangular carton B to hold the product they are marketing for the first time. Both containers have the same volume. Tin A has a radius of 3 centimeters and a height of 10. So its radius is 3 and its height is 10. Find the volume of the tin. So you go to your tables and you look up the volume of a cylinder formula. So the volume of a cylinder is equal to pi r squared h. So what we're looking to do now is we're going to put pi r squared h into it. So you get into your calculator, put pi from your calculator, r squared, which is 3 squared, and height is 10. Enter all of this into your calculator, and what you should get is you'll end up getting 90 pi. Now 90 pi is an answer if you want it in terms of pi, but you can also press the S -D button, and this will change it into decimals for you. And what we'll get is 282.7433, and you can round that off into 282.74. And look at your units to see what we need it in. It's in centimeters. So what we're going to do next is centimeters squared. Carton B has a square base, okay? So what we have to remember, carton B is it has a square base, okay? Of length 5. So it's 5 by 5. The volume you got in A above to find out. Carton B has a square base of 5. Use the volume you got in A above to find the height of carton B. Give your answer to one decimal place. So we're told is to hold the same amount, okay? To hold product in market for first time, both containers have the same volume. So the answer for the cylinder is the answer for the volume of the carton. So volume of carton, B is 282.74. Now the volume of a carton, we don't know the height. So what we can say is that the volume of carton is length by breadth by height, which is going to be 5 times 5 times h, and that equals 282.74. Next thing, 25h must equal 282.74. Now 25, the h, we need to get h on its own. 25 is multiply on the left, which means when we bring it over the right hand side, it has to turn into divide. So h is going to be 282.74 divided by 25. And what we're going to get is the height, therefore, must equal. So we just rub this out for a minute. The height, therefore, must equal 282.74 divided by 25, you're going to get 11.3. 11.3096. Answer, give your answer correct to one decimal place. So if it was one decimal place, it'd be 11.3. You could round that up to 3.1, but 3.1 rounds down to 11.3. Okay, so the answer is 11.3. Which one of the containers above do you think the company might use? Give a reason for your answer. Okay, so we can see that they both have the same volume. Okay, so I would use they both have the same volume, but the cylinder is shorter. Okay, so the cylinder has a height of 10. Okay, while the B has a height of 11. Okay, so what we're thinking we might use here okay, I'd use a cylindrical container, and the reason why I'd use the cylindrical container is it has a smaller height. It has a smaller height than has a smaller height than the has a smaller height than the box container, which means you could pack more in. You could store more in each box. Okay, that's one argument. The other argument is you could also say that you'd go with the you could go with the box, right? I'll tell you why. You could also say that if you were to stack cylinders into a box, okay, what you notice is there's a lot of free gaps, okay. So anytime you put a cylinder in, you're going to get free gaps. Okay, so what's going to happen here is you're just going to have lots of these, okay. Circles, okay. And when you have lots of circles, what happens is there's lots of free space. So the free space here, you're going to notice that anytime you put a cylinder into a box for storage, there's free space here. Well, if I was to put boxes in, each cylinder has a width of 6, while the box has a width of 5. So although the box is taller, you can also say that the boxes will fit more easily in for storage, okay? So that's another way. So the boxes give away no free space, okay? So that's what we can say about that. So what we can also write down for this answer. You can argue both ways. To be frank, you can do a height argument, or you can do a space argument, right? So container, the box, container B, the box. Reason, if you're shipping them, if you're shipping or if you're boxing this container in boxes, it uses the space more efficiently. Because the cylinders obviously gave away the cylinders. If you put the cylinders into a box, the cylinders don't occupy all the space. You can see the black area here that the cylinders would be. They don't use all the space because they can't fit in exactly like a box would. So all the black area here would be free space that hasn't been used up. Okay. Okay. Mary is planning to fly to London. The table shows the flights leaving Dublin Airport and arriving at London Heathrow Airport on a particular day. So here we go. This is Dublin, and this is arriving in Heathrow. Mary needs to arrive at Heathrow by 10:30. What's the departure time of the latest flight she can take to Dublin Airport? Look at the arrival times. Too early, too early, too early. This one's after 10:30. So this is the flight you have to... Is it before or after 10:30? She has to arrive by 10:30. So because she has to arrive by 10:30, what we can say is that this one's too late, but this one's just right, just 15 minutes before 10:30. So the answer would be you're leaving Dublin at 10 to 9. Okay, so 10 to 9, 8:50. Okay, find her time of flight in hours and minutes. Well, she leaves at 8:30. She leaves at 8:50 and arrives at 10:15. So 10:15 minus 8:30, 8:50. Okay. So what we have here is basically we got to take it away. Okay. So what we're saying is 50 is bigger than 15. So what we can do is we can borrow an hour. So what we can change 10 hours is, remember, there's 60 minutes in 1 hour. So what we can say is that 10 hours 15 minutes is the same thing as 9 hours 75 minutes. Okay, take away 8:50, and what we're going to get is 75 minus 50 is 25 minutes, and 9 minus 8 is 1 hour. So 1 hour 25 minutes. Mary would like to arrive in Dublin Airport 45 minutes before that flight leaves. At what time should she arrive at the airport? Okay, 75 minutes is 1 hour 15 minutes. Okay, her flight leaves at 8:50, 8 hours 50 minutes. So you take away 1 hour 15 minutes from this, and what you get is she should arrive at 50 minus 15 is 35. 8 minus 1 is 7. So she arrived at 7:35 a.m. in the morning. Okay. Next part. Mary checks in one bag. The cost of checking in the bag is €25. The fare summary for her journey is given in the table below. Find how much the taxes and charges amount to. Okay, so we have to find out basically the total is 3,388. Let's take away the baggage of €25. And then let's take away the fare, okay, which is €74.99, and then we can check on the taxes this way. So let's put this into the calculator and see what we get. We're going to get €33.89. Okay, that's the end of that question. So we're on the next one. Okay, so the distance from Dublin to London is 464 kilometers. Find the average speed of the airplane during this flight. Now you have to remember is your distance, speed, time triangle, okay? DST. Cover up whichever one you're looking for. Find the average speed. So we're looking for speed. Let's shade this one now. What's left is distance over time. Now, what we know is that the distance is 464. Alright. Now we have to find the time for the flight, which is in the last question here. We'll just go down. Find the time of the flight. It's 1 hour 25 minutes, okay? Now please, you don't want to make a mistake with this, okay? What you have to realize about the time is that it's 1 hour and 25 minutes out of 60. It's 25 minutes out of 60, so don't write down 1.25. That would be wrong. So what you want to write down is 1 hour 25 minutes out of 60. So you put this into your calculator, 464 divided by. Now above the fraction button, I press shift. Press shift on the Casio calculator, then press the fraction key. And when you press the fraction key, what you'll get is something that looks something like this. And all you gotta do is enter in the number. You gotta enter in the number 1. This is 25. And this here is 60, okay? So 1,464 divided by 1 and 25 out of 60. Okay? And you'll get 327.53 kilometers per hour. Okay, next one. A survey was conducted among third-year students. The answer to the survey questions can be classified as categorical data, where the categories are not ordered, ordinal categorical data, discrete numerical data, or continuous numerical data. In each row on the table below, write a short question that you could include in the survey, and that will give you that type of data. Okay, so the first thing we need to know is what are these types of data, okay? And what do they mean? So we'll just write down the meaning of each one, so we know what each answer should be, okay? Now, categorical data means categories, okay? So an example would be categorical where the categories are not ordered. Okay, so categories. So an example would be, what is your favorite football team? Who is your favorite football team? Now, the reason why this isn't ordered, okay, the categories aren't ordered because an example would be you could get Liverpool, United, Manchester United, Celtic. There's basically no order to that, okay? There's no order, like there's no numbers in this, okay? Now, if you want ordered categorical data, now once again it has to be in categories, okay? So an example would be, I'm trying to think now, example would be, it could be what type of house do you live in? Now what type of house is a category? Okay, and because it's a category, okay, what we can say is that we live in a 1-bedroom house, a 2-bedroom house, house, 3-bedroom house. So you can see there's an order here, but it's very much categories, okay? 3-bedroom house. Okay, bedrooms, house, okay, so that is example of ordinal data. Another example of ordinal categorical data could be the likes of opinion scales, okay? So opinion scales. So I could say, do you agree with homework? Okay, so opinion scales, okay? And you could say strongly disagree, 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 neutral. You could say you agree and you strongly agree. So you can see that there's an order here, okay? Now, next one, question 3, discrete numerical data. Discrete numerical data means, discrete means it's either, let's say 1 or 2. So let's say, how many goals did you score in a match? Did you score in a match? And the example of discrete numerical data would mean either score 1 goal or 2 goals. You don't score 1.5 goals. It's impossible to say you score 1.5 goals. So it's basically usually whole numbers, and you either score 3 or you score 4. There's no debating. You score 3.1 goals. Okay. Well, continuous data would be what's your weight? your weight in kilograms, let's say. Now, an example of weight in kilograms is, I might say I'm 78 kilograms, but in reality, I'm probably 78.013 kilograms. I'm never quite 78 kilograms. I'll always be slightly under it or slightly below it. Okay, so basically, continuous numerical data is on a scale. So another example would be how tall am I? Okay. Or if you ask another discrete numerical data, it'd be what marks did you get in the exam? Did you get 9 out of 10, 8 out of 10, 7 out of 10? Okay. Short question, you could do it and get that type of data sort. Okay, Grant. Next question. Okay. The following question was asked on phase 9 of the census skill questionnaire. Approximately how many hours a week you spend on social networking sites? This is stuff like Facebook. The data below are from two examples of students chosen random for UK and Ireland. Okay, number of hours. 0 people spend only 1 hour. Okay? 1 person from UK spends 2 hours, 1 person from Ireland spends 2 hours. 2 people spend 3 hours, and 2 people from the UK spend 3 hours. 3 people from Ireland spend 3 hours. Okay, and this is the way the table works. Okay, you can see that nobody from the UK spends 7, 8, 10, 11, 12, 0, 0. Okay, so just fill in gaps as you need them, and we see that the UK, we have some students that spend much longer on the network sites than in Ireland, but then at the very end, 4 people from Ireland spend 25 hours, while only 1 person from the UK does. How many students are there in each sample? To get the students in each sample, we got to add up all the numbers. So for the UK, we've got to add up all these numbers in here. So you're just going to get out the calculator and add them all up, okay? So here's what we do. We're just going to add all of these up, okay? So 1 plus 2 plus 1 plus 2 plus 7 plus 1. Now just be really careful not to make any mistakes here, okay? Because the mistakes are relatively easy. 4 plus 1 plus 5 plus 5 plus 2 plus 4 plus 5 plus 3 plus 3, and currently here, plus 2 plus 3 plus 2. Okay, I got 50 students from the UK, and now I'm going to count up Ireland. So I'm going to get star here and count how many students there is. So it's going to be 1 plus 3 plus 2 plus 2 plus 2 plus 3 plus 5 plus 2 plus 3 plus 3. Currently here. Plus 4 plus 2 plus 5 plus 1 plus 2 plus 4 plus 2 plus 4. And there's also 50 from Ireland, so there's an even sample of each one, okay? Okay, so in this part it says, display the data in a way that allows you to compare the 2 samples. Use separate display for each sample, okay? So what I'm going to decide to do here is I'm going to decide to do a histogram, okay? So what we need to do is we need to arrange it into equal intervals, okay? So we need to arrange it into equal intervals. Now there's 25, okay? 50 students in total, but each one there's 25, okay? So what we could say is, let's arrange it into segments of 5, okay? So we go 1 to 5. Okay, 1 to 5. Next segment can be 6 to 10. The segment after that can be 1, 2, 3, 4, 5, right, 11 to 15. We'll do is the next segment after that, 11 to 15. Okay, segment after that can be 16 to 20. And then finally the last segment can be, just so we don't have to count every single sample, it can be 21 to 25. Now what we need to find out from each segment is, this is the segment from 1 to 5. Number of hours, 1 to 5. So how many English students, British students, UK students was there from 1 to 5? So 3 plus 3 is 6 from the UK. So UK is 6 and Ireland is 4, 8. Okay, then we can go down to the next one. The UK is 8 people here, and Ireland is going to be 5 plus 5, 12 people watching from 6 to 10 hours, okay? So this is 6 to 10 hours. And then the next segment can be 11 to 15. Okay, so where we're going to get 10 and 6, 10, 12. We're going to get 12 in this one. And then finally, from 16 to 20, we're going to get 7, 11, 16, 19. This one here we'll get 6, 8, 12, 14. Okay, then we're going to get 5, 6, 7. So 7 here and 4 here from 21 to 25. Now, what we're going to do is we're going to draw a histogram, okay? So the histogram, we have to see what our highest number is. We have to go as far as 19, okay, on our scale. Okay, so our histogram will be on the next page. Okay, and let's count how many blocks we have. 3, 4, 5, 6, 8, 9, 10, 11, 12, 13, 15, 16, 17, 18, 19. Okay, so we actually have 19 blocks. Okay, so we should be okay with that. Now, we have 19 blocks here, so what I'm going to do is just going to draw my axis. Okay, and we'll use a black line here. So I'm going to draw my axis like so, and this is for the one histogram each. Okay, so what I might need to do, because I'm going to have to fit them both in, is I'm going to have to use as much space as I can. So I'm going to draw it right at the edge. Okay, so we can see, and roughly use half, divide the page in half, okay, because you don't want to go over the halfway point. Alright, so the halfway point should be around here, somewhere along here. Okay, so what we're going to do is we have 5 intervals. Okay, so 5 intervals. We need to count how many blocks we have across. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Alright, so 15 would be ideal to use. So I use 15 blocks. So I can do it in blocks of 3. There we go. Okay, so what we're going to do is we're going to arrange it into, basically, this is going to be 1 to 5 hours. The next one is going to be 6 to 10. The third one is going to be 11 to 15. The fourth one is going to be 16 to 20. Stops here. And the last one's going to be 21 to 25. Okay, and this is going to be for the UK. Now, what you also want to do is you just want to so I want to do this from up here. I want to make an exact copy of what we just did a second ago. So we go here. Now we're going to move this right the way over, so we have enough space. There we go, just the right amount of space at the moment to do this, okay? So then we go up here. Okay. And this one here is going to be UK is the first one, and Ireland is the second one. Okay, and this is, and we had to label both axes, okay? So this is number of hours. And this one here is also number of hours. And then we just got it. We might go up just up in threes on this axis because this can be number of people. 6, 9, 12, 15, 18. Okay, so we can just go up in we can use the same scale on both axes because we might be 3, 6, 9, 12, 15, and 18 there. Okay, so what we're looking to do next is we got to find out the numbers of each one. So we go back to the previous page. So it's 6 and 8 for the first two. Okay, so 6 and 8. UK versus Ireland. 6 and 8 for the first two. 8 and 12 and 10 and 12. 8, 12, 10, 12. Next one after that is going to be 19 and 14. And then the one after that would be 7 and 4. Okay, so what we're going to do is we're going to go about drawing this now. Okay, so we need to draw a histogram. So the UK 1 to 5 is going to be 6. So make sure it lines up 1 to 6. The next one is 8 for the UK. So go to line 8, like so. The third one is 10, which is going to look like this here. The next one is 19, which is going to be up here. And the one after that is going to be 7, which is here. Okay. Now the last one, just you might want to space that out a bit better. You could use a gap of 2, maybe to space it in a bit better. Now, onto the Irish one. We go on 8 on the first one, which is here. 8 people. Then we're going 12 people for the next one. And then we're going 12 again for the third one. Just 11 to 15 margin. And then we're going 14 for the next one, which is 16 to 25. And then 4 for the last one, which is 21 to 25. So that'll give us the 4, which should be here. So you can see that these are two histograms of the data. Okay. Based on your answer in part B, write down one similarity and one difference between the two samples. Okay. They only have one mode. Now what a mode is the most common or the highest amount. So the mode is 16 to 20. Most students in Ireland and England tend to spend between 16 to 20 hours on the social networking sites. So they have the same mode of 16 to 20. To 20. Okay. You could also say that the maximum number is also up to 25 hours. So max time spent is 25 hours. Okay, these are similarities. Okay. Now, if we need a difference, the difference can be anything that you find are different from both samples. Okay, so you can say that we can Also comparative mode, more people in the UK spend between 16 and 20 hours than they do in Ireland. Okay, so 19 people in the UK. Now it appears I wrote this peak down wrong. It's meant to be 19 here, so this top part doesn't matter. It's extra. Okay, so this part here is just a bit wrong. It was meant to be 19 people only, not 20. Okay, so this is 19 people. So that's wrong. So the 19 here. Okay, so 19 people in the UK. Okay, spend 16 to 20 hours, while only, we can look at here, 14 people in Ireland spend 16 to 20 hours on the social network sites. Okay. Now, another difference could be you can pick any one of them you want. Okay, you can say that a higher amount of Irish people spend less time. So if you look at this area here, a higher amount of Irish people spend less time on this. A higher amount of Irish people spend a lower amount of time on these networking sites. Okay, so that's another difference. Okay. Now, is it true there any difference between the Irish and UK regarding the time they spend on social network sites? Explain your answer. So that could be the answer I'm answering here. In general, people in the UK spend a higher amount on the social networking sites, while the people in Ireland seem to spend a lower amount of time on the social networking site. So you can see that more people in Ireland spend lower times on the social networking site. Okay. So yes, in the UK, much more. Now, what we're talking about, students or students? Okay, so we're talking about students. Okay, so in the UK, much more students spend, let's say, over 16 hours on the social networking sites. Sites. Okay, next question. Okay, a bag contains red discs, blue discs, and white discs. In an experiment, each student of class of 24 takes out a disc, records the color, and replaces it. This is repeated 10 times. The results in the class are recorded in the table below. Okay, so red came out 123 times, blue came out 78 times, and white came out 39 times. Okay, so calculate the relative frequency, which is frequency over total. So 123, we need to get the total here. So what we got to do is we got to add all three of these together to see the total amount of times we actually performed this experiment. So we actually performed this experiment 240 times. Okay, so 24 students repeated it 10 times. So if 24 students repeat it 10 times, it's 240. So hence, when you add them all up together, you get 240. So what we got to do next is we got to get relative frequency is, what you're looking to do is 123 over 240. The next one is 78 over 240. And the next one is 39 over 240. Now check all of them into your calculator. Just make sure they're in the lowest fraction possible. This is 41 out of 80 when you change it. The next one is 13 out of 40. And the last one is 39 divided by 240. Not 340, 240. And what we get here is 13 out of 80. Okay. Now, to get the percentage, we need to multiply these by 100. So just multiply them by 100. And what we're going to get is 16.25%. The next one is 32.5%. Now remember, all three of these have to add up to 100% because there's only three outcomes, so they all have to add up to 100% when you add them together. So 21.25. So they actually all do add up to 100%. Okay. In your opinion, why is the number recorded for red greater than for blue or white? There must be more red. There must be more red discs in the bag. Than blue or white discs. Discs with a C, okay? Complete the table above. We just did that. Use the results taken from the table above to estimate the probability of getting each color when a disc is taken from the bag. Okay, so we actually did estimate that it's going to be 41 out of 80. This one here is 41 out of 80. The next one is 13 out of 40. And the one after that would be 13 out of 80. Okay. Anne says she thinks there are 10 discs in the bag. Is this a reasonable suggestion? Explain your answer. Okay. Look at the percentages. 50%, 51% could be roughly 5 and 10. 32% could be roughly 3 and 10. And this 16% you could round up to 2 and 10. And what you can say is, yes, this is reasonable, as you could have 5 red, 3 blue, or so 3 blue, and 2 white. 2 white. This could give similar results. Based on the information in the table, how many discs of each color do you think are in the bag? Give a reason for your answer. If it was to be exact, we could say that this blue one is 26 out of 80. And we could say 80 discs. We could say 80 discs. And the reason is the probability for all of these could be red probability is 41 out of 80. Blue is 26 out of 80. And white is 13 out of 80. This amount of discs matches the probability. Just make any relevant argument you can, lads, okay? Just that fits the results. Okay. Okay, so estimate the probability of each of the events A, B, C, and D listed below. Write your answers in the table. Okay, a name is picked at random from 50 girls and 50 boys. The girl's name is picked, right? So it's going to be 50 over 100. which is a probability of a half. A fair coin is tossed once. Head is the outcome. Once again, there's two outcomes, heads or tails. It's also going to be a half. One card is drawn at random from a pack of playing cards. The card is a diamond. Okay. Now remember, there's 52 cards in the deck. 13 of them are diamonds. 13 of them are spades. 13 of them are hearts. And 13 of them are clubs. So diamonds going to be 13 out of 52. Put that into your calculator. It's going to be a quarter. A day is chosen at random from a list of days of the week. The name of the day contains letter A. Now remember, they all end they all have A because they all end in the word day, and day has an A in it. So it's going to be 7 days out of 7 have an A in them. So it's going to be 1 or 100% chance. Okay. Now, this one here is a 50% chance. That's a 50% chance. If you want to do percentages, this is a 25% chance. Alright. One number is picked at random from a set of 1, 2, 3, 4, 5, 7, 11. Each number chosen is a prime number. Well, believe it or not, 1 is no longer considered a prime number. So 1, 2, 3, 4, 5, 6, 7. So there's a 6 out of 7 chance of that happening. Okay. Place the letter of the events on the most appropriate position on each scale, right? So A is 50%, which is 0.5. B is also 50%, which is 0.5. C is 25%, which means it will go dead center between the two of them at 0.25. D is 100%, which would be here. And E is 6 over 7. So 6 over 7 is roughly 86%, so it will be somewhere up here, E. Okay, it'll be over halfway, so that's E there. Write down another event that has a probability similar to C in the scale above. C is a 25% chance. Okay, so let me see. You can say a bag contains 1 red and 3 blue discs. Probability of getting a red is 1 in 4. Of pulling a red is 1 in 4. Okay, write down another event you think has a probability similar to that of D in the scale above. So D is 100%. Trying to think something that's dead certain. Something that's dead certain. Probability that the sun will rise. Probability that the sun will rise, or maybe there will be cars on the road, is another one. Very dead certain at this point in time. Okay. In a multiple choice quiz, there are 3 possible answers are given to a question. Jamie does not know the answer and guesses which one is correct. Put an X on the scale above to show the probability that he does the correct answer. So 3 possible answers. He does a 1 in 3. 1 in 3 multiplied by 100 is just going to be around 33%. So 1 in 3 is 0.3333. So we need to figure out that. It's more than 0.25, so 0.333 be around here. Okay. So that concludes the first, I think it's the first 7 questions. Okay.